I'd like to welcome you to today's webcast, Advanced Energy Design Guide Recommendations, Lighting Overview, the first in the three-part series on the AEDGs, brought to you by the U.S. Department of Energy's Building Energy Codes program. For those of you wanting continuing education credit for the event today, a link will be provided at the end of the webcast. AIA members should write down the link and go to that link and provide us with their names and AIA membership numbers, and we will submit the information to AIA for their credit. In addition, anyone wanting a certificate of completion to self-report to a professional organization should write down the link to go and generate and print one. We're very happy to have as our speaker today, Michael Lane with the Lighting Design Lab. Welcome, Michael. Please begin.
Thanks and welcome. My name is Michael Lane, and I'm here today to talk to you about an overview of the lighting recommendations for the Advanced Energy Design Guides. Here's a little bio of myself. If you want to find out more information, I work with the Lighting Design Lab in Seattle, Washington. I've been doing lighting for about 26 years. Read it, have fun with it. For those of you who aren't that familiar with the Advanced Energy Design Guides, and even for those who are, just a little refresher here on what these are. These are a guide book. They're about 100 pages long, and they're designed to give to a contractor, architect, engineer who doesn't either have the wherewithal, the time to go through and design a building that is more energy efficient than ANSI ASHRAE IES standard 90.1 1999 version. And it was done on the 99 version primarily because the first guide that was out, the office guide, that was the standard that was really in place when that guide was being developed. And all the subsequent guides have used that as the base standard, and many times the question has been asked, well, why not update the standard to the 2001 or the 2004 standard? And then the reason that it hasn't been and that the 99 standard is really still the base is that was the standard that was kind of in place at the turn of the millennium, and so it's kind of that base case that all of them are going to be judged against. Ultimately, the plan is that there will be some 50% guides. There was some talk of some 70% guides, and then 100% to net zero energy buildings. So that's why it was based on the 99 standard. You can get the guide either a couple of different ways. You can go to the ASHRAE or IES website. Those are two of the main sponsors for it. You can see the sponsors there at the top of this page. It is, again, something you can buy. You can also go and you can see that on this slide here that it's a free download. As a PDF, you can sign in and you can download the 4 guides that have been finished so far. And again, here are the sponsors for the guides. We have the American Institute of Architects, Department of Energy, of course, ASHRAE, U.S. Green Building Council is a sponsor, as is the IES. On the first guide, which was the office guide, USGBC was not a sponsor, but the New Building Institute was a sponsor, but on all the subsequent guides, New Building Institute was not a sponsor, and USGBC was. So these were very, very fast, not the typical ASHRAE standard type of process. These were all completed within about a year. I was actually have been on 3 of the first 4 guides, and I'm actually on the 5th guide, which we don't have a cover yet, so it's not on this presentation. We basically did all the meat of it in about 6-7 months, and then it gets turned over to publications, and final work gets done on them, and then ultimately they do get published, of course. Again, 30% was the goal on these guides, to be 30% energy savings relative to 90.1 1999. They're all based on the 8 different DOE climate zones, which means that you have to get the savings in Fairbanks, and you have to get the 30% savings in Miami, and all the 6 different climate zones in between. It's not an average. It is each different climate zone has to meet the requirements. Again, if you have a copy of the guide or can look through it or haven't got a copy of the guide, they're all laid out about like you see on this slide. There's an introduction, talks about some of the things that I've already talked about today, the process of how we went through and developed the guide. There's recommendations by the 8 different climate zones, and these are 1 to 2 page documents. There was even some talk early on that these would be laminated sheets that could be pulled out so that if you were only doing work in climate zone 4, for example, you could take out that recommendation sheet, put it on a clipboard, and even take it to the job site if necessary, or to an architect's office, or wherever you were going with it. You'd have that one page that were all of the recommendations that you needed. From the beginning, there's always been case studies, technology examples built into the guide in the original one, the office one. They were actually built into the climate zone, so you'd have the climate zone recommendations, and then the next page was a case study. And the second guide, the retail one, they were moved out into their own little section, chapter 4. And then probably at least a third to, if not half of the guide are how-to recommendations. So, and again, we're dealing with lighting in this talk today. When you get to chapter 5, the lighting section, there'll be all these how-tos. Some of them will deal with issues around daylighting and how you would bring daylighting into a building, or occupancy sensors and what type of occupancy sensors you should look at using, or how you would meet the lighting power density recommendations in that climate zone table. So there could be 10 tips on daylighting and another 20 of them on electric lighting, and then maybe there's even a third section which varies by the guide that you're actually looking at. There's a bonus savings section, and in many of the guides, exterior lighting ends up in a bonus section. In the last guide that we're working on right now, which is highway lodging, we're actually taking some of the new recommendations out of the 90.1 standard that have just been adopted. They're actually post 2007 standard ways to do things, and we're doing some things on climate zones, and at the end we'll take a quick look at some of those. This gives you an example of the 8 different climate zones, and they span the country, and there's hot, humid sections, and there's marine climates. I'm from Seattle, so I'm in climate zone 4 in the marine section. But those climate zones you can see go all the way across the country. And because of that, we didn't just pick one example location in each climate zone, and in a couple of slides we'll see some of the example cities. It was actually modeled, I think, under 15 different cities throughout the United States, again, from Miami all the way to Fairbanks. If you open up one of the guides, here's a climate zone 4 recommendation table. This one is out of the office guide. We will see, of course, the envelope recommendations, and there's recommendations for the roof, walls, floors, slabs, doors, vertical glazing, and skylights, and different recommendations by different types of building materials that you're going to use. There's also a section specific to lighting. There's a specific section on HVAC and surface water heating. So getting into the first one of the 4 guides in more detail, and again this talk is more on the lighting section. The first guide was the small office building guide. This was designed for recommendations on small office buildings, and small office buildings were defined as a 20,000 square foot or less building. There were actually 2 models that were done. There was one done on about a 5,000 square foot office building, single story. There was also a design done on a 2-story, 10,000 square foot floor plate, so a 20,000 square foot office. And those two models, when they went through the 15 different climate zones, were looked at and kind of averaged together to say, oh, if we're doing a really small office building versus what we call a small office at 20,000, did they vary and how much did they vary? And then we put those kind of averaged those together to get the final recommendations. This slide that you're seeing now, it kind of gives you an idea of the breakdown, and I only have this one for our office buildings. And again, at the top, you can see that this was for a 5,000 square foot office building. But what's interesting in this slide is if you look at the savings and lighting, the first column there in yellow, you can see that the savings over the base, and the base again was the 1999 standard, was about 36.6%, which if you scan down between Duluth and Miami and Phoenix and Seattle, you'll note that it's always 36.6%. That was the nice thing, is that lighting is not something that is really climate zone specific. If I do the electric lighting in Duluth, that same electric lighting design can be and therefore should be used in Seattle. Once you get into a few more advanced techniques that were barely modeled in the office one, and we start to see them show up much more in the schools and the warehouse guides, is where we really start bringing daylighting and using that daylighting savings for the modeled savings. You do see some variations by climate zones on basically the availability of daylighting. So if we go back to this chart for a second, you look at it and you go, yeah, we got 36.6% savings, but in Duluth that only counted for 16% of the savings, where in Seattle it counted for almost 54% of the savings. So it does, other factors are much more important, of course, in Duluth, the heating. And how you can change that envelope or the systems that go into the heating were much more important than they were in Miami. We can see there's no heating savings, and the savings in lighting and then in cooling were the more important or dominant savings locations. So in the office guide, again, we started with the 99 standard, which the base watts per square foot were 1.3 watts per square foot. At the time, the 2004 standard was out when we started developing this guide. So we took, first step was to say from a lighting standpoint, okay, what's in the 2004 standard? We can't do anything less than the 2004 standard. That became our new base, even though it was modeled against and the savings were based against the 99 standard. The 2004 became a kind of a hard floor we couldn't go below. We then said, well, what else could we do? Well, one option would be to say, could we push that a little bit more? Could we go from the 1 watt per square foot to maybe 0.9 watts per square foot? And we did that. We did some modeling, used the existing, the lighting subcommittee, the 90.1 lighting subcommittee. We have a series of models. There's like 126 different models, and you can change some of the inputs to those models, and one input you can change is how efficient the fluorescent lighting system is. So we changed it to what's called a high-performance lamp, which I'll talk about a little bit more detail in just a minute. And that got us down to a 0.9 watts per square foot. So yeah, it's only 10% below the 2004 standard, but it gave us that 37% approximate savings versus the 99 standard. Also recommended the use of occupancy sensors. The 99 standard had very little on controls, so let's use occupancy sensors in all those private offices, in the conference rooms, in the storage rooms. Daylighting, it really wasn't used as a heavy energy-saving mechanism, but we did say that we did need to see daylighting controls on the north and the south sections of the building. We didn't do it on all four sides because daylighting on the east and west, not that you can't get savings from it, but it's much more difficult to control the daylighting as it comes into those sides where the north and the south are much easier to control the daylighting. So one of the measures we used were high-performance TA lamps. And if you're not familiar with these, you might have heard them called premium or super or enhanced or high lumen. There are a variety of different lamps that are made by the major lamp manufacturers. that all produce about 3,100 initial lumens, and they have very good lumen, what we call lumen maintenance, so 2,915 mean lumens. They all provide good color rendering. They're in the 85% range, and they had, at the time we were doing this, some of the longest life lamps at 24,000 hours, which was 4,000 hours more than the standard lamp or the lamp that was used in the 99 standard. So next slide, we see here's just a repeat of what we saw a few moments ago in the full table, but this just breaks down the lighting part of that table. We see that the power density, again, 0.9 watts per square foot. We didn't specifically say high performance lamps, even though we could have here, we said 90 mean lumens per watt. And part of the reason we did that is because lighting technology changes. And if we put in a lumen per watt rating, a new lamp could come out and it could be used. But if it wasn't really classified as a high performance lamp, there'd be issues with it. There we see the recommendation for the dimming controls on the north and south walls and within 8 feet of a skylight edge. There's no requirement that you actually install skylights, but if you were to install skylights, we want you to control the light fixtures that are around that skylight. We want to see occupancy sensors in unoccupied rooms, so your storage rooms and restrooms, those types of spaces. One of the other things that doesn't seem like it relates to lighting, but it's very, very important, is interior room surface reflectances. So we want to have high reflectances, 80% on the ceiling, 70% on the walls, and vertical partitions. So we don't want dark materials inside that office. Because we are starting to push the limits on the lighting power densities, we want to keep the space feeling nice and bright. As I said earlier on the high performance lamp, here's just showing you a chart, and if you look at the right hand column, you can see the mean lumens per watt. And you can see that there's a couple of lamps that are below the 90, and one of those is kind of highlighted, hopefully in green. On yours, about halfway down, it says F32T8, and there's a /7XX. That's the lamp that is built into those 90.1 energy models for lighting. And we can see that if lumens per watt, mean lumens per watt, are only 83. So we are pushing that lamp up to what is really not the standard lamp that people are designing with. It is a lamp, of course, made by about 4 or 5 different manufacturers, so it's not one. There's a little bit extra cost to using that high-performance lamp. We also broke the space down because you think offices, and it's like, oh, we're dealing with private offices and we're dealing with closed offices. Well, in those, going back to the 90.1 models, it's not just those areas. We also have about 10% of the area that's in corridors, about 10% in lobbies. The open office makes up about 20%. The enclosed office, private office, makes up about 25% of the space, and meeting rooms, conference rooms, 10%, and storage about 15%. And then if we applied the lighting power densities that you see there under the LPD column, that gives us our total LPD of 0.899, so just under our 0.9 watts per square foot. And up in the right-hand corner, you'll see kind of a diagram, and it's probably hard to see on the screen there. But if you actually had the guide, either the PDF version or the hard copy version, when you got to the lighting how-tos, one of the sections would actually show you one way to do the lighting in the space. And if that was a little bit bigger, you'd be able to see a pendant-mounted fixture. You'd also see a task light in that space. So that gives you an example of one way to meet the target 30-foot candles maintained and 50-foot candles on the desk. This is something that after it was done got put into LEED, so it's one of the prescriptive options. And yes, in the 2009 version things are changing, but that hasn't completely gotten through public review. But in the LEED NC 2.2, you'll see that this is one of the options you can use to get 4 energy points. You have to do the whole thing. You can't just do, say, the lighting section, but if you do the whole guide, you can get 4 energy credits. The second guide was small retail. As I said earlier, I was involved in the development of the small office building. I was also involved in the development of the small retail buildings. Again, 30% energy savings over 1999. Again, a 20,000 square foot approximate size. Again, we modeled different size of spaces and actually different types of functions when we got into retail. We modeled functions, let's say, like a drugstore versus a clothing store versus, say, a jewelry store, because we have different, in this case, lighting requirements of how you would actually light the space. And so the recommendations under retail got a little bit more advanced, a few more recommendations that were there. So again, just like we saw with the the office guide, we see that we started with the base of the 1999 standard, 1.9 watts per square foot. The 2004 standard became the de facto base that we couldn't go above on watts per square foot. So it's our new base. The recommendations for high-performance lamps continued from the office guide, but we added in another component there, which is high-performance ballast. And we will talk in a couple minutes about what are high-performance ballasts for the fluorescent lighting systems. We also changed the technology in the 90.1 lighting guides from halogen IR incandescent lamp to a ceramic metal halide lamp source. It is a more costly lamp, but we are seeing some really great energy savings and significantly longer life out of that lamp. And we'll have a slide on that in a couple minutes that talks a little bit more about it. Again, occupancy sensors, but only in the back of house. We don't want occupancy sensors out in the retail sales floor that turn off the lights when there's nobody there. That could happen, and we definitely don't want to see spaces go dark. The high-performance ballast is a product that's been out for, well, about 3 or 4 years, maybe a little bit longer than that. And you can see on this chart there's 4 different manufacturers. The Obtainium is an advanced product. The Ultra is a GE product. The QAG QTP is a Osram product. And the Ultimate is a universal lighting product. And if you look at this table, there's kind of a yellow bar right in the middle. That's for your normal light output ballast. And a standard ballast today that we would typically see in about 85% of installations, a 2-lamp T8 electronic ballast, is using about 58 watts. Well, these new high-performance electronic ballasts, we can see there that they range from 54 to 55 watts. It slightly varies whether I'm running 120 volts or 277 volts. It might actually jump up a watt if I'm running 120 volts versus 277 volts. But that would happen both in the normal, the standard electronic ballast and in the high-performance electronic ballast. So we're getting about 3 to 4 watts savings. Doesn't sound like a lot, but when you've got hundreds of them, those 3 to 4 watts add up pretty darn quick. The lighting recommendation table that we see here drops the lighting power density for the general lighting to 1.3 watts per square feet. We tweaked up the mean lumens per watt to 91 mean lumens per watt for your general fluorescent lighting, which is what you would typically find in most retail. All other sources, like your accent lighting, we're seeing 50 mean lumens per watt, and that compares to the halogen IRs that we would see in the 90.1 models of 50 mean lumens per watt. So that gets us into the ceramic metal halides. We're looking at dimming fixtures within 10 feet of the skylight edge. Assuming you're putting in skylights, we want you to dim those. And 10 feet instead of 8 feet on the office guide was put in because we're assuming higher ceiling heights. We don't have any recommendations, and actually we would recommend against dimming or switching off any lights near the entry of the retail space, because that does tell the customer that the store is open. And if we shut those off, we could actually adversely affect sales. Controls, again, non-sales areas, we want to use occupancy sensors. And again, if you're doing daylighting, want to see those reflectances very high to, again, bounce that light throughout the space. There's a second section that's kind of hidden a little bit behind the cover of the retail guide that talks about additional interior lighting power allowances. And this was a big part of the retail guide of how do we deal with that. If we go back to the 99 standard, we'll actually see that there were recommendations for general accent lighting, and then there were recommendations for featured or fine merchandise lighting. And that was 3.9 watts per square foot for the fine merchandise and 1.6 watts per square foot for the general merchandise lighting. And it got a little bit more specific on what we actually could highlight with those. And so in the 2007 standard, it was updated to do kind of 4 different space types, and you can see those kind of listed there on the right-hand side under recommendations. So jewelry, crystal, and china, for this example, get an additional 1.5 watts per square foot. We didn't specifically say you couldn't use halogen IR, and we'll see in a couple of minutes how come you still could use halogen IR instead of ceramic metal halide. And we also have a recommendation on externally illuminated signage to try to keep that at about 0.2 watts per square foot. So ceramic metal halide is a relatively new technology. It's been out for at least 5 years. It looks a lot like your halogen IR par type lamp, but it does take a ballast like any metal halide lamp. It's not something I can just take out there and screw into my existing incandescent fixture. But there's some real benefits of it. We can see here that these are 35, 39 watt lamps with ballast, maybe running about 44 watts. The lumens are comparable, if not above, what we would see with a halogen IR technology, but they're using significantly less power, and their life is 3 to 5 times longer. Color is very good on these. You do have to be a little bit careful about mixing halogen IR with the ceramic metal halide, let's say on the same wall that you were trying to light up, because there would be a slight difference in the coloring of those 2 lamps. So here's kind of a build-up of how we got to the lighting power recommendations for retail spaces. So here we have the base lighting, 1999. We assumed about 70% of the space at 2.1 watts per square foot. We assumed 20% in storage, 5% in office, and 5% in other spaces. And so that gets us to about 1.82, which earlier on, a few slides ago, we talked about 1.9 watts per square foot. So that's kind of how we built up to that 1.9 watt per square foot in the 99 standard. And then as I briefly mentioned, there's an additional power lighting allowance in the 99 standard, and it's carried through into the 2007 standard. You get 1.6 watts per square foot for general accent lighting, or 3.9 watts per square foot. So we ran a number of scenarios, and you can see kind of in a orangey, salmon, pink, whatever color it's showing up on your computer, that we looked at 50% of the accent light at 1.6 watts per square foot. The second one from the left-hand side, all 1.6 watts per square foot, and then total them up, we can see now if we're using that whole 1.6 watts per square foot, we're almost up to 3 watts per square foot, or the one on the far right-hand side, 70% of the space at 3.9, we're up to 4.55 watts per square foot. So that was kind of done in the 99 standard. In the 2004 standard, you can see kind of in a red type there, a little bit got changed, and it talked about the specific display area. And this really became confusing to a lot of code officials and to designers. So in the 2007 90.1, we made a major change, and that's what we were briefly talking about before. And so here we've taken kind of that new number, which is using ceramic metal halide, to get to that same scenario of the 50%, the 100% at 0.58, and that number comes actually just from a mathematical equation of what was the efficiency, the efficiency of ceramic metal halide versus the efficiency of halogen IR technology. Now, in the guide, we we wanted to see that ceramic metal halide, but one of the reasons why we left in that you could use halogen IR technology was this table here, which is an IES RP2, Recommended Practice 2, which is for merchandise lighting. It talks about a variety of different spaces, and we kind of group them all together. And you can see the first one, grocery, supermarket, warehouse, stores, discount drug, convenience, mass merchant. But they gave us high and low recommendations. So if you were to actually take the lower recommendations of light levels, and there's nothing that really defines whether you should take the high or the low. A lot of times if you look at this and say, well, I really want my customer to be able to understand everything by themselves, you might go towards the high recommendation. If you want to have them have help, you might tend to go towards more the low, but it doesn't really matter. You could go either way. If you want to meet the high recommendation, you almost have to use the ceramic metal halide. If you can live with the low recommendation, you could maintain using halogen IR technology to get the levels that we see here. And so here's what we did for the 2007 standard. I know we're talking about the AEDGs, but we took this and we applied that ratio of the ceramic metal halide to halogen IR technology to get the additional power recommendations that we saw in the AEDG. You see 1.7, 2.6 watts per square foot, 4.2 watts per square foot. So this is where the recommendations came from by, again, applying that ratio that we see here in this slide, basically multiplying everything by 0.36. And that's just using the lumens per watt of the two various sources. Again, this one does show up in lead retail. You can use this if you're doing lead for retail. Again, follow all the recommendations. You get 4 energy credits, and this will probably change with the new LEED 2009. The third guide was K-12. This was one of the guides that I was not involved in, but this was focusing on K-12 schools. Just like the others, there was one variation, but just like the others, this was based on the 99 standard, again, achieving 30% savings. The size changed from that 20,000 square feet up, and I'm not sure exactly what was modeled from a size standpoint. You know, schools aren't 20,000 square feet. They're typically significantly larger than that. So this one got to change. Again, we see that the 99 standard would have allowed 1.5 watts per square foot. Actually, the 2004 standard, I'm trying to remember, I think it's 1.2 or 1.3 watts per square foot, and so it's a little bit of a typo there. That it really, in the AEDG, it ranges from 0.9 to 1.2 watts per square foot. Manual on occupancy sensors were recommended for turning off lights during unoccupied hours. And the difference between a standard occupancy sensor and a manual on occupancy sensor is that with a manual on occupancy sensor, you physically do have to touch it, just like a wall switch, to get the lights to turn on. And this is very advantageous, especially in areas where you do have daylight into the room, even though you're not necessarily counting on daylight for energy savings. Why walk into a room that you're immediately going to turn around in and have that occupancy sensor automatically turn the lights on? So you have to hit the switch basically to turn the light on, but after you leave, then it will automatically turn the lights off. Daylight controls, this was one of the first guides that daylighting really became one of the major players of energy savings in the lighting section. That daylighting controls were required for fixtures within 15 feet of the north or south window walls and within 10 feet of a skylight edge. Again, just like we saw all the other different climate zones, here is the climate zone 1 and 2, and we'll see here that it slightly changes from a lighting section. This is the first one where the lighting recommendations really change due to climate zones. So we can see in climate zone 1 and 2, the lighting power density for that first upper section that says interior lighting daylighted option is 1.2 watts per square foot maximum. And the mean lumens are 75 mean lumens per watt. And this is actually different, and we'll see here shortly, but this is a different mean lumens per watt than what we've seen so far. This one actually takes into account the ballast efficiency, where the first ones didn't. They were just the raw lumens per watt. Look in the catalog, here's the lumens, what are the watts of the lamp, divide the two. So that 75 sounds low, but it's actually a little bit higher than that if you look at it with the ballast included. You'll notice that down below this, there's also a section on interior lighting, non-daylighted spaces. And you can see that the watts per square foot are at 1.1 watts per square foot. The mean lumens jumped up to 85 mean lumens per watt on the fluorescent linear sources. And as we jump through the different climate zones, we see that in climate zone 3 and 4, in the interior lighting, non-daylighted option, we can see that our watts per square foot have gone down. And again, I wasn't involved in this, and being involved in 4 of the 5 total guides, I can understand or hypothesize why this change was made, and that is that in climate zones 3 and 4, they are a little more benign, let's call it, from a heating and air conditioning standpoint, at least in parts of those climate zones. So they needed more energy savings from the electric lighting system to get that full 30% energy savings. So that's why we see a little bit lower watts per square foot in climate zones 3 and 4, just to beef up the savings we were getting from the lighting system. 5, 6, 7, and 8, we can see that number has gone back up to 1.1 in the non-daylighted classroom area. And here's a table, one part of the left-hand side of that table where you see all the kind of aqua or blue color is actually from the guide, and I've added in on the right-hand side 2 columns that say AEDG SO, which is for small office, and SR, which is for small retail, and the requirements there of 90 mean lumens per watt and 91 mean lumens per watt, and how that would relate to what is shown on this chart. And what you really see is that in the small office version, it matches up with the far right-hand column of the 32-watt T8 high-efficiency system, and the lumens per watt that you see in that column, they match up perfectly. In the small retail one, you can see that there's a series of NAs, so it wasn't actually available to use some of those technologies, and what you're seeing is that on the far left-hand column are ballast types, and then we have in the columns different lamp types. So the reason why it says NA is that those are not what we consider high-performance electronic ballasts. Only the bottom 4 are truly considered high-performance electronic ballasts. So it was a variation, a different group of people working on it. There's nothing wrong with doing it this way. It provides maybe a little bit more options for meeting the efficiencies of different ballast and lamp combinations in the system. The 4th guide in the series is for small warehouse buildings. Again, 30% savings over 99. Again, this changed the space size up to about 50,000 square foot warehouse, and we also looked at self-storage buildings. This was a guide, again, that I was involved in. And this was also a guide that we did need the savings from daylighting in the warehouse spaces to meet the 30% goal. In the 99 standard, again, the base was 1.2 watts per square foot. In the 2004 standard, it drops to 0.8 watts per square foot. We are seeing a requirement of somewhere between 5 to 7% of the floor area in skylights. So if you've got 50,000 square foot off or warehouse building, you need 5% of that or 7% of that, somewhere in that range, in skylights in the ceiling to daylight the space. We want to see automatic daylighting controls on all those electric lighting systems in the daylit space. We want to see occupancy sensors on those same light fixtures so that when the space is unoccupied, the lights go off. And this is a very simple thing that you can do from the manufacturer. They can come with an occupancy sensor either built into the fixture, or you can put them on rows down the aisles to turn the lights off. We want a T8 high-performance system, and that's basically the lamp and the ballast. They're both high performance. Or you could use T5HO technology, which is different size lamp. It's a 5/8 of an inch diameter lamp. It works very well for high ceiling applications. The high output lamp, you can basically use half the number of lamps that you see in a T8 system. So you get less lamps up there. Optically, the fixture becomes more efficient, even though if you were to look at lumens per watt, it's a little bit lower. So here's again the breakdown of what we see. We're seeing that the general warehouse making up about 75% of the floor area. We dropped the lighting power density to 0.6 watts per square foot. We also have a fine storage area that we're assuming takes up about 20% of the floor area. And the difference between those two, general warehouse is large, bulky items. You might have 25-foot high racks. Fine storage might be nuts and bolts, small things that are hand-selected instead of that are selected with forklifts. So we need a little bit higher lighting power density in that fine storage area. And then the recommendations for the office are just the recommendations that we see from the office guide at 0.9 watts per square foot. So we can see that our total is about 0.67. Get a little bit more accurate now when we get to these lower numbers. We don't get to necessarily just to get a nice round number. From a lighting standpoint, if you're actually going to go through and look at this and how much light you're providing in the space, our target level was 10 average maintained vertical foot candles. Now, a lot of times, if when I throw out vertical, you're questioning what that is. A lot of times we'll talk about horizontal foot candles. Light on the floor, light 2.5 feet up on a desk surface. It's the light that falls on those surfaces. Vertical foot candles we'll use in a situation like this where we've got stacks and we need to look 15, 18, 25 feet up in the air and read a label from that forklift and pull that product off of the racks. So that's the difference. We want to have 10 average foot candles on the face of that product, not on the floor. We don't really care how much light's on the floor. And here's the recommendation table. Just like we've seen before, we see, in this case though, skylights. We're seeing, again, that 5 to 7% of prismatic diffusing skylights required in the warehouse area. We don't, if you're doing a self-storage type of building, we did model that, but we're not looking for skylights in the self-storage areas. There are some recommendations on the thermal transmittance, and that does change on the thermal transmittance, field solar heat gain, and visible light transmittance. Some of those we're going to change if you look at the different climate zones, but I haven't included all those pages here. The 0.6 watts per square foot, the 0.85 watts per square foot, and the office area is 0.9. And then again, the recommendations for the high-performance lamp or high-performance electronic ballast with the T8 system, or a T5HO technology, which only comes with really one type of ballast today. We want the controls for the daylight harvesting because we want to shut these off. We've got these skylights there. Let's shut off the lights. Occupancy sensors on the fixtures. Again, the ceiling is going to be very important. The reflectance value of the ceiling is going to be extremely important for a couple of reasons. One, the light's going to bounce around. That's coming out of the skylights down to the product, down to the floor. It's going to bounce around, and it's going to help light the ceiling so that when I look up at the ceiling, I don't have this real bright object in the ceiling, and I'm trying to look at a product, and if I got a light-colored ceiling, that brightness is going to, the contrast ratio is going to be mitigated. So we definitely want to see that happen. And if you do have exterior areas, again, we were looking at a 50,000 square foot warehouse, so we did have kind of the dock area, the loading dock area, and you're going to have some lighting under there. So we want to kind of keep that to about 0.5 watts per square foot. Now we did, again, because we were including daylight into the space, we did model the four different climate zones with the building to see how much savings we could get, and the initial target was to try to save at least 50% of the lighting energy by using skylights. And so we used this program called SkyCalc, and here we've got Miami, and we're getting about 63% of the lighting savings by using this system. In Phoenix, we got 62%. In Seattle, 50%. The daylighting in Seattle actually works pretty well. We do get a lot of overcast sky days here, but it still can work fairly well. You can see at the very bottom our skylight to floor area ratio, FR, is at 5.9%. So we're in that range where we need it to be. And then Duluth, 57% energy savings. We did model, again, every climate zone ultimately, and this is one area, if you were to look at the tables, you would see that in Fairbanks, we actually took the skylights out. It wasn't that we weren't getting energy savings. We were getting really good energy savings during the summer months. But the heating penalty, because we were trying to heat this building to maintain 50 degrees, if we had these large openings in the ceiling, in the winter months, it really was a heating penalty. And we were getting virtually no daylight savings in about 2 to 3 months of the year in the December, January, February time frame. So we did take out the skylights in Fairbanks. You could probably still use them, but you'd need to figure out some way to cover those skylights for those 3 months so you didn't have all that heat loss through the skylights. So there's some additional lighting guides that are on their way. I mentioned highway lodging, and that one's underway right now. Publication date, of course, to be determined. Shortly here, I'm going to give you a little bit on that guide so you know what it's about, what's coming from that. There is, they are trying to do an advanced energy design guide on existing buildings, something that luckily I guess I haven't been asked to be involved in. And again, 50% guides on some big box retail, and then additional guides on the ones that have already been done, things like the K-12, small office, small retail, and those committees haven't been formed yet, but they're going to take these further and see how much more energy they can save. And again, just as a point here, last meeting I was at, this was talked about of the 1999 guide versus the 2004 standard and how much energy we're saving, and the analysis that's been done, if I understood the comment correctly, is that all of these guides so far have still met 30% goal, even over the 2004 90.1 standard, even though they were based on the 99 standard. So that means that some of these are probably achieving 35, maybe even 40% savings over the 99 standard. So in the lodging guide, just a quick little history on what's going on with that one. Again, the 99 standard was based on 2 watts per square foot. The 2004 standard was 1.0 watts per square foot. So that became our new base. The compact fluorescent lamps with electronic ballast was the new model, whether that was in the rooms, in the hallways, in the lobby space. We wanted to see compact fluorescents with electronic ballast. We also want to see some type of master control at the entry and a vacancy control in the bathrooms. Some of that is like the vacancy control in the bathroom is a 90.1 new requirement. We also want to see if it's a multi-story building, and we modeled a 4-story and a 2-story. The 4-story was an internal corridor. The 2-story was an external corridor. So in that internal corridor one, we want to see bi-level control on the lighting systems in the stairs. And that basically means that, you know, at 2 o'clock in the morning, when there's probably nobody walking in the stairs, there's still at least 50 or around 50% of the lighting. You could actually go less lighting than that, and it's an automatic system typically built into the fixture. Again, manual on, auto off occupancy sensors in all laundries, office, exercise buildings, business center, meeting rooms, and non-public spaces. To get those lights, again, you have to physically turn them on, but to get them to automatically shut off. This is just a breakdown of what we see. Again, 70% was guest rooms, 13% corridors, 11% main lobby, which actually did include a little bit of that office reception type area, and about 6% laundry. And that's not public laundry that we're talking about. That's laundry for all the towels and sheets that are typically done on site in the building. And so here's the recommendation table. You can see that we've got a few more spaces here in the recommended light levels, or recommended watts per square foot. 0.74 for guest rooms, corridors 0.5, exercise 0.9, meeting rooms 1.1, and so on. Compact fluorescent lamps, again, with electronic ballast. You could use T5HO or high performance with high performance electronic ballast if you were doing, let's say, linear fluorescent in the corridor. There's no reason you have to use compact fluorescent. Again, the bi-level occupancy sensors and manual on. Guest room controls, those maximums there. Plug load, very important to consider the plug loads, because if you really think about, and this is true in both the lobby space and in the guest room lighting, a good percentage of the lighting that's in those spaces are plug loads, especially in our guest rooms. And we need to get those to compact fluorescence with electronic ballast to really meet, and that was actually part of the recommendation, so we couldn't not count that energy savings from the plug load. We needed that for the energy savings. This is the one area from an exterior standpoint where we really see a lot more information in the guide, because this is, again, taking some new recommendations that are in 90.1. They're not in the 2007 standard. They're an addenda to the 2007 standard, and these are basically recommendations that are saying, if I'm designing my building in a downtown core of a city, I need more light because of the ambient light that's in that environment. There's other buildings, there's street lighting, versus if I took that out into a more rural environment or a more residential environment where we tend to find more of these highway lodgings, we don't really need or want that same exterior light level that we would see in a downtown area. For one, there's an adaptation issue that if I have a very dark environment and I brightly light an area, as I drive into it, my eyes will adapt to that higher, brighter level. When I then leave that environment to the street, my eyes take some time to adapt to that lower light level. And that's actually a safety issue. I might not see a deer or an object in the middle of the road. So if I can kind of keep that light level more in tune with the environment that the buildings are in, I can save energy, and I also reduce the issues of light pollution and light trespass. So you can see at the very bottom there's lighting zone 2 and lighting zone 3. If you were to look at the addenda for 90.1, there's actually 4 lighting zones. Lighting zone 1 is really, truly rural. And we didn't think these really fell into that environment. And lighting zone 4, the kind of downtown core areas, and again, we didn't really feel that highway lodging fell into lighting zone 4. So there's some recommendations on parking area and drives and canopies and facade lighting that vary due to those 2 zones. And here's just showing you how much energy from an exterior standpoint you might save by doing that. So the 2004 standard on the model that we did, it was an actual plan of a hotel building with all the parking around it, that if I were to use the 2004 standard, and you're asking, why not the 99 standard? Well, the 99 standard was extremely vague on exterior lighting, and there were very few requirements. It was pretty much just a requirement on lumens per watt, and I could have actually lit that exterior parking lot to maybe 1 watt per square foot. There was no real requirement. So in 2004, actually had some specific requirements for walkways and pathways and parking and so on and so forth. So we used those as the base. We get almost 9,300 watts to do it. If I were looking at zone 3, where zone 3 and zone 2 are really where we want these to fall, 5,600 watts or 3,500 watts. Zone 2, it's almost a third of the watts that we would see if we add in some facade lighting, because many times these hotels will want to light up some of the facades. Again, we're seeing maybe 2/3 of the energy in Zone 3 and less than half the energy on that exterior environment in lighting Zone 2. So that's giving us a brief overview of the AEDG series. And again, sorry I don't have an image because I don't think we've chosen an image yet for the highway lodging one. Please go to the ASHRAE website and download the PDF version of it, or even better yet, go buy the paper copy. I have both. I like to have both. There's times that I can find the information a lot faster if I'm dealing with the paper copy, but I always like to have it on hand when I'm traveling, and it's better on my computer that way. And that concludes the presentation.
Well, thank you very much for an informative webcast, Michael.